as always, when we give ourselves a new rule, let's make sure that we can do the rule without it. Or rather, we can do the problem without the rule. We have a rational function here. Y is equal to x plus 1 divided by x squared minus 1. And we want to differentiate y with respect to x. That is the derivative with respect to x of x plus 1 over x squared minus 1. And the first way that we're going to solve this is simplifying first and then differentiating. The derivative with respect to x is still there. That numerator is as simple as it can get. That denominator, though, factors. We see cancellation. Right, so this function and this function are equal everywhere except when x is equal to 1. But who cares about that one single point? Because derivatives, you need balls around points so that you can have a tangent line. All right, I'm even going to rewrite this again. I'm going to bring that x minus 1 up to the top with a negative power. This is now minus 1 times x minus 1 to the minus 2. And the derivative of the inside x minus 1 is just 1. So we're done. We can clean it up a little bit. Minus 1 over x minus 1 squared. Okay. Now when we differentiate, we will use the quotient rule, right? When you looked at this and you said, oh, I have a function divided by another function, immediately what comes to mind is I can use the quotient rule. So let's remind ourselves of what the quotient rule says. If you have a function f divided by g and you want to differentiate that quotient, it is low d high minus high d low over low low. Right, the numerator is kind of like the product rule, except it is important which one you start with. You have to start with not differentiating g multiplied by the derivative of f. Else you'll get the negative of what you want. All right, low d high minus high d low over low low. So when we differentiate x plus 1 over x squared minus 1, let me double check that was the function. Yep. If we follow that pattern, it is going to be low d high, the derivative of x plus 1 is just 1, minus high d low over low low. All right, so us going through that pattern is us taking the derivative. So I no longer have my derivative operator. That is the derivative. So the calculus is done, but it looks a lot different than our answer over there. So let's use some algebra to simplify. 1 times x squared minus 1 is just x squared minus 1. And let's distribute that negative and the 2x. So minus 2x squared minus 2x over x squared minus 1 squared. Our numerator simplifies a little bit. X squared minus 2x squared gives you a, x squared minus 2x squared gives us a minus x squared. And then minus a 2x minus a 1 over x squared minus 1 squared. Hopefully we can recover this. If I take a negative 1 out of that numerator, I get x squared plus 2x plus 1 over x squared minus 1 squared. And that's a little bit more obvious to me. This is minus 1 times x plus 1, x plus 1. All right, and that x squared minus 1 has an x minus 1 and an x plus 1 inside of it. Oh man, this is a lot of algebra. at least if you want to show it in as much detail as I'm going into. So you probably saw the conclusion a mile away, but you can distribute that square in that denominator. The x plus 1 squareds cancel with the 2 up there, minus 1 over x minus 1 squared. Right, same thing that we got over there. Usually the quotient rule is actually faster. In fact, there's going to be functions where you can't simplify it and you actually do have to use the quotient rule.